Hello scholars, welcome back to the channel. What we're going to look at today is divisibility. Long word, but what it really means is we're going to be able to look at numbers and decide which number they are divisible by, just by following certain rules or patterns, right? So divisibility, what is it divisible by? Which number can we divide into it equally without getting a remainder? So I'm just going to run down these notes. You know, sometimes maths is theory. Many people think of maths as being this practical thing all the time, and it is practical. And actually, the more hands-on you are able to be in mathematics, the more you will understand the concepts, and the more you will, learn and remember the principles, the formula, right? So, but much of math is theoretical. And I always say, as mathematicians, you need to work hand in hand with your dictionary. Because the meaning of words, the meaning of the terms used, the actual meaning as it's used in the language, whether the language of origin or the language that is used now, it can really help you to understand the principle, the concept of that, right? So always have your dictionary on hand to check the meanings of these mathematical terms. And you'd be surprised how much they can help you in understanding the concepts. So I know the board looks like an English language class today, right? It looks very much like an English language class. It's full of notes, full of theory, but mathematics has that aspect to it. So I'm going to go through the terms and I'm going to explain them as we go along. So these are the clues that we use to decide what number can we divide into any given number, which numbers are factors of that number. So let's start with 0. So no number is divisible by 0. We can't divide by 0 because when we divide by a number, we should be able to do the inverse and prove that it is true. You know, division and multiplication are inverse of each other. And if we divide by a number and get our result, our quotient, we should be able to multiply the quotient back by the divisor and get back our dividend. That's how we prove. So we use division to prove multiplication. We use multiplication to prove division. With the 0, remember 0 times anything is 0. So if we were to divide by 0 and get an answer, it follows logically then that we should be able to multiply that answer by 0 to get back the original number. But when we multiply something by 0, we always get 0. So there's no number which, when you divide it by 0 and get a result, you're able to multiply 0 by that result and get back the number. Once you're multiplying 0 by a result, you're going to get 0. So then, for the 0, we say division by 0 is indeterminate. We just can't do it. It's not logical to do. Alright? But we can divide 0 by a number and that answer will be 0. Alright, so for the 1, remember 0 and 1 are really special numbers in maths. The 1 is called a universal factor because every number is divisible by 1. Every number can be divided into groups of 1, equal groups of 1, and the result will be that number. So if we divide 5 into groups of 1, we're going to get 5 groups of 1. 100 divided by 1 is 100 groups of 1. So all numbers are divisible by 1, and we will get back that same number. If we divide it by 1, we get it back. Universal factor. Okay. All numbers are divisible by themselves. We often take that for granted, but we need to remember every number can go into itself once. So if we have 20, we can divide it by 20. We get one group of 20. 56 is one group of 56, right? So every number is divisible by itself once, exactly once. Any number divided by itself gives 1. Okay. So all numbers are divisible by 1, and all numbers are divisible by themselves. The prime numbers are only divisible by themselves and 1. Nothing else can divide into them. So they follow these rules that all numbers will follow. They can go into themselves, and 1 can go into them, but nothing else. So prime numbers have only 2 factors. Only 2 numbers that divide into them exactly. Themselves and number 1. And these are our first set of prime numbers. So the prime numbers below 20, 2, and 2 is the only prime number that's even, because the other even numbers are divisible by 2. So that means they would have at least 3 factors. Prime numbers can have only 2 factors. So 2 is the only even number that is prime. 2, 3, 5, 7, 11, 13, 17, 19 are the first set of prime numbers. Only 5 and 1 can go into 5. Only 11 and 1 can go into 11. Right? Only 19 and 1 can go into 19. So those are the prime numbers. A number is divisible by 2, or it's an even number, if it ends in 0, 2, 4, 6, or 8. So those are our set of even numbers. The numbers that are exactly divisible by 2 are called even numbers. And they end with a 0, a 2, a 4, a 6, or an 8. It doesn't matter how many digits are in the number. It doesn't matter how big the number is. Once that digit at the end is a 0, 2, 4, 6, or 8, that's an even number. It's exactly divisible by 2. If it doesn't have the 0, 2, 4, 6, 8, that means it will have the 1, 3, 5, 7, or 9. And in that case, it will be odd, not divisible by 2. A number is divisible by 5 if it ends with a 5 or a 0. So again, it doesn't matter how many digits the number has or what the digits are at the front and the middle. We look at that last digit. If it is a 0, if it is a 5, 5 can go exactly into that number. Whether it has 6 digits, 10 digits, 100 digits. That last digit at the end, if it's a 5 or a 0, 5 can divide into that big number or that small number, it doesn't matter. Alright, so we're here. A number is divisible by 10 if the number ends in 0. Only numbers that end with 0 are divisible by 10, exactly divisible by 10. Right? So 10, 20, 40, 160, 3,000, 410, 450. Once it ends with a 0, or 2 zeros, 3 zeros, 9 zeros, it is divisible by 10. And I think most persons just know that off the bat, right? You look at a number, it has a 0 at the end, 10 can go into it. And remember, when we're dividing by 10, we simply cross through that 0. Just cross off that 0 for the whole numbers. For the decimal, we just move one place to the left. and ignore what's to the right after that, if it's just 0. Okay? Alright, so we did the 0, the 1, the 2, the 5, the 10. Okay? So we're at the 4. How do we know if a number is divisible by 4? The law says, and remember, these mathematical laws, we call them laws now because we are benefiting from the work that has been done, the arduous, tedious, tiresome work, in some cases the work of a lifetime, of mathematicians who lived before us. We can just reel these off now. Just reel them off one after the other. But many of these took years, decades, centuries, a whole lifetime of work by many, many persons doing trial and error and looking at patterns and comparing patterns and seeing that this thing keep happening over and over. So now we can, say, okay, so this is the pattern, this will always be the case. And now we can just reel these things off, but we have to be grateful. We have to thank those mathematicians, some of whom spent their entire lives trying to understand the principles, the mathematical principles. So we now know, thanks to them, we now know that if a number is divisible by 4, the last 2 digits of that number is a multiple of 4. Is divisible by 4. So it doesn't really matter what comes before the last 2. We focus on the last 2 digits. If 4 can go into the last 2 digits, the entire number is divisible by 4. How do you think we know this? It must have been trial and error over many, many years, many, many decades, centuries. And we study the patterns, right? So, and now you can try it for yourself. Think of any number you can write down. Once the last 2 digits are multiples of 4, check to see if 4 can divide into it. 396, 4 can go into 96. 4 into 9, 2 times, 4 into 16, 4 times. The entire number then is divisible by 4. Try it, work it out and see. 4 into 39, 9 times remainder 6, 4 into 36, 9 times. Sorry, 9 times remainder 3, and then 4 into 36, 9. So that's 99. 1012. 4 can go into 12 3 times. So we know that the entire number is divisible by 4. 6,348, 4 can go into 48. The entire number is divisible by 4. Work it out. 4 into 6, 1 time remainder 2, 4 into 23, 5 times remainder 3, 4 into 34, 8 times remainder 2, 4 into 28, 7. So all of these numbers, you can set them out and divide them and see if it works. And write down numbers of your own. Just write down some digits. But make sure that the last 2 are multiples of 4, and then you divide the entire number and see if it works. Don't just take, just because I'm saying this is a law, check it for yourself and see if you can come up with an exception to the rule. How about 3? A number is divisible by 3 if the sum of the digits in that number is divisible by 3. So what that means is, if you add up all the digits, if you add them, if it's a multiple of 3, if 3 can go into it, then the entire number is divisible by 3. So 1041, if we add the digits, 1 plus 4, that's 5, plus 1 is 6. 3 can go into 6, so the entire number is divisible by 3. 573, 5 plus 7 is 12, plus 3, 15. 3 can go into 15, so the entire number is divisible by 3. 8,016, 8 and 1, 9 and 6, 15. 3 can go into 15. See? So you just add the digits, separate the digits and add them. And if that number is a multiple of 3, then 3 can go into the original number that you had. Same for the 9. How do we know if a number is divisible by 9? If you add the digits and you get a multiple of 9. So 4 plus 5, 9, and 9, 18. 9 can go into 18. So 4,590 is divisible by 5. 6 and 1, 7 and 7, 14, and 4, 18. 9 can go into 18. So 1,674 is divisible by 9. 5 and 8, 13, and 3, 16, and 5, 21, and 6, 27. 9 can go into 27. So 58,356 is divisible by 9. Okay? And why would we need to know? Why would we need to know off the bat if something is divisible by another thing? Well, sometimes you just want to estimate. Let's say you have something to distribute. You have 9 groups of 9 classes, and you have a certain number of things, and you want to know, am I going to be able to share this equally? And you probably don't want to go through the steps of dividing. You just want to make a quick estimate, a quick idea. Just add up the digits and you say, yes, I'm going to be able to divide this by 9, or I'm going to be able to divide this by 3. Right? We know some of them are pretty easy, like the 5, once it ends with a 0 or 5, immediately 5 can go into it. The 10, once it ends with a 0, off the bat, 10 you can divide it into groups of 10. Immediately you know that, right? Even numbers, 2 can go into them. 0, 2, 4, 6, 8. Once they end with that. So the others, just take a little bit, maybe another step of adding up the digits and then seeing, right? But there are ways of knowing which numbers are divisible by certain of the digits. And remember, this is thanks to all this knowledge, all this theory that we have, all these formulae, all these laws, principles. We can reel them out now, but they took many, many, many years, many decades and centuries and lifetimes of trial and error, studying patterns. So we really need to thank our mathematicians who lived before us, centuries, millennia before us, right? And now we as scholars of mathematics can benefit from all of these, knowing all these principles and applying them to our lives. Or if you have benefited from this video, just drop a line to say thank you, miss, and share the video so others might benefit as well. We can't be selfish. Share the information. Subscribe if you haven't done so, and let me know if you want me to do a video on any topic at all. So take care, and I'll see you in the next video.